All right. In this movie, we're going to review how to make equations and then create a plot. So first of all, rho, the density of air, we'll use 1 today. Okay? And that's in kilograms per cubic meters. And the velocity, and then the cross-sectional area, let's see here. We have pi. Yeah, it's kind of strange, but you get pi like that. Just like that, pi times the diameter squared, so caret 2. Remember, we start with an equal sign. And then we want to divide by 4. Okay, because it's pi r squared, but here we're not using r for the radius, we're using d for diameter. Okay, so that's twice as big as the radius. So if we square the radius, well, if we're squaring the diameter, we have to divide by 4. Okay, so there we go. Now the coefficient of drag, again, you're going to start with an equal sign. We're going to take the drag and we're going to multiply it by 2 because we're just moving all these variables to the left side. So multiply this side by 2, it cancels, of course. And then we're going to divide by rho, which is simply 1. And then we're going to divide by the cross-sectional area. And then we're going to divide by the velocity squared. So take the velocity and squared. Okay. Now instead of doing these divide bys, I could have done multiply and multiply here, but I would have wanted to wrap the entire denominator in parentheses. So either way should work. So there's the coefficient of drag. But I've got some issues here. The B3 rho is a constant, so I want to put a dollar sign up there. Okay, so I put a dollar sign between the B and the 3. And then the B6 is also a constant, so put a dollar sign there. And the B4 is a constant, so put a dollar sign there. And now when I fill the formula down, I'll find out the coefficient of drag. And it looks like, wow, this one, the hollow sphere, has the greatest coefficient of drag, which is what we expected. And then the airfoil has the least. That's also probably what we expected. So let's use rho down here, the same value, 1. And then I can just copy this formula for the cross-sectional area and paste it right there. And it's just going to use the value right above it, the diameter. And this was for the hollow sphere. There's my data. So I want to find the velocity squared. So I'm going to take equals velocity squared. And then put my click right there and put my mouse in the lower right corner and drag down. So there's my velocity squared. And I want to plot the drag versus the velocity squared. So in order to create a plot, well, first of all, we already know the slope here because it's found it with this is the y-axis and this velocity squared is the x-axis. To create the plot, I'm going to highlight the x-axis first. So I'm just going to start with the title and highlight down to there. That's all I did was just highlight. And then I'm going to use the command key, which is right next to the space bar. So hold the command key at this point and drag from drag to 0.27. Okay, so let me click over here and do that again. I'm just using the mouse. I'm not touching any keys, and I'm going to highlight from velocity squared down to 121. Then I'm going to hold the command key and go from the word drag down to 0.27. And again, the command key is next to the space bar. On a Windows machine, you'd use Control. All right, and then we can go into the charts. So right here, there's charts. And we have line, column, yada, yada, yada. Well, none of those is what I want. So I'm going to choose right here for all, insert chart, all, and go down. And I don't want a line, don't want a pie, and do not want a bar. I'm looking for scatter plot. And so there's the scatter plot. And I don't want to connect the dots or not show the data points. I just want to show only data points. So I'm going to choose this one right here. And so there it is. Now this plot, I can click once on the data. Here, let me do that again. And then I can right click. Or you can just start by right clicking on data and add a trend line. And then under options, I want to turn on display equation and display the r squared. And the r squared tells us how linear it is. If r squared is 1, the data is perfectly a line. Okay. And now I want to right click right above the legend in this white space right here. Right click and move chart. New sheet. And let's call this D versus, what was this? Velocity squared. Oh, it doesn't like funny characters in here. So there it is. Now in the chart layout, so up here there's charts, and then there's chart layout. That's where I add a title. So we can add a horizontal axis title and just type away. Hello. Oops, too many times. So just click here. This is going to be, what did we say? Velocity squared. Okay. And we want to square that, and then we'll do meters per second and square that. Okay, so I type it out first, and then I highlight the 2. I just held the shift key and back arrowed, and then I right click, and now you're not going to see this because it's off the movie. So let me just move this up here for a second. I'm going to highlight the 2 and then right click and choose Format Text. And I can turn on a superscript and do the same thing for this one. Right click, Format Text, and turn on, oh, I lost it, superscript. There we go. So there's velocity squared. Let me put this back where it belongs. And then I go up here to axis titles and vertical axis. No, that's not how I like it. I like it this way. And then we just say drag. That was in newtons. There we go. Oops, don't hit return there because it'll make it 2 lines. So there's your plot. There's your linear fit, drag versus velocity squared. And just to do this again, we'll make another plot here. Rows 1. And the cross-sectional area is equal to diameter times pi. And we do those silly parentheses after them. And then divided by 4. But I forgot I need to square my diameter here. And then fill that down. And now we want to plot drag versus cross-sectional area. So again, we're going to highlight the area first. That's the x-axis. And then hold the command key to highlight the y-axis. Okay, so we highlight from area down to there, and then command key, drag down to there. And then we go up here into charts. We choose all, and we find scatter. There it is. And right click, add a trend line, and you might want to be careful here because some of you might actually have a polynomial. It might not be very straight, but this data looks pretty straight. And there's a reason for that. I want you to think about that in terms of last week's lab. What happens when you put a larger diameter object inside that wind tunnel? What happens to the flow rate? Well, flow rate should be constant. So what happens to the wind speed, the velocity of the air? And then I won't belabor this anymore, but chart layout, that's where you add in your axis titles. And then right click and move chart. New sheet, give it a good name, and there it is. So that's how to make charts and a review on how to make equations. Oh, that's different. Oh, there's my data. All right.